Welcome everyone to this talk on linking survey data. So why do we talk about linking survey data? That means combining survey data with other types of data. Combining different types of data provides the best of multiple worlds. Survey data is great for doing social science research. It is the backbone of much of the data-driven social science research. And necessary to understand the social phenomena we're interested in. But it is not sufficient to understand all social phenomena we're interested in. Survey data has its drawbacks. Because respondents may be biased in the way they recall certain events. They may have spuriously changing perceptions that are not due to the factors we're interested in. They may respond due to social desirable properties, and survey data doesn't provide information on the context or on the actual behavior of the respondents. Other data types can add crucial information to survey data and remedy these shortcomings in a way. Geospatial data, for example, provides physical context information the respondents are embedded in. Digital trace data can tell us about their actual online behavior. Expert-coded data can provide us with consistent assessments of the institutional traits of institutions that respondents interact with. And official statistics can provide us with consistent information about society that no other data source could provide us with. Due to all these advantages, many social scientists engage in data linking every day. Nonetheless, many challenges remain when we link data, and also inefficiencies when everyone tries to link data on their own. And here we want to present some of these challenges today.
I would start, as it's the good tradition, with a definition of linking, especially as we understand it for this presentation. And linking in a broad sense, of course, is just simply combining data from multiple sources for joint analysis. So this could also refer to linked open data applications or any kind of data linking. But for our department, as it's called survey data curation, the most important is that we focus on linking survey data to data that are not generated through surveys. So we want to link or to discuss linking of survey data to non-survey data. And this is always possible if you have an interface that you can use to link the individuals to other information from individuals or groups. But the most important at this moment is that our focal entity for linking is always the survey respondent. So this focus, of course, has to do with the work that we are doing at our department at GESIS, where we try to have many of these interfaces available for our users. I'd like to give a short overview of how we conceptualize linking in a very general way at our department. So we assume that if you're doing social research, you have a kind of multidimensional data space. Here I present a model with only 3 dimensions. The first, of course, is time, and then people are living or acting in a space. And what's most important, we also have different units of analysis in social research, because individuals, even if they act on their own responsibility and their behavior in the end are individual, they are always embedded into larger social structures. So our focal unit is an individual. And in our case, an individual that is surveyed at a specific moment in time, let's say T0. And of course, it's always possible to locate the individual in the space where it's living, working, or moving. And in many cases, you have like panel designs where you survey the same individual multiple times. But this is not the way the type of survey linking that we are talking about, because this is simply a repeated survey. And you can also, of course, ask people about what has been in the past. So we always have a kind of temporal structure in surveys if we want the temporal structure to emerge. And what we also have in many cases, and this is a kind of first step of interesting linking, is to ask people about other people that are close to them. There are significant others, as it was called in the 70s in sociology. And this is the basic setting that we have in many surveys, that we have an individual with people from closer family households networks that are surveyed multiple times or one time, and sometimes we collect information about their past. And then, of course, these individuals are part of groups that interact with each other. And here it becomes even more complex because now we need more techniques, for instance, to determine what is the network of a person, what is the group this person is living with. So this is the first unit, a level of analysis to some extent, that we not only have the individual, but also the groups that this individual is part of. And this is something that you can study with linking applications as a kind of network analysis, and that is today often being done with data from digital behavioral domain, like social media platforms. And then we have even more aggregated units that are organizations that are crucial for social research. Different kinds of organization, political, social, economic, or just leisure time organizations. The German Football Federation is the largest federation of associations in Germany with a lot of members. And of course, all this is embedded into regimes, nation states, or subnational units of nation states. And for our linking concept, the most important is that everything can change over time. So regimes change, of course. This is a very harsh change where a regime disappeared, but you always see institutional change at the very aggregate level that might affect behaviors at the individual level. Multi-level analysis has been developed for this. And we can also track what organizations do through time. So if a regime changes, political parties change, and any kind of organization changes through time. And at our department, we are now discussing to have a more integrated view on data linking by covering all the relevant spaces or dimensions of the data space. So having longitudinal data, modeling the space where people live, comparative research designs, for instance, and now addressing more systematically more aggregated levels of actors like political parties, also media outlets, etc., and regimes, and makes the survey data linkable through time and space to these higher aggregation units. And if you look, and of course this is a point I almost forgot, there is always the issue of the sensitivity of the data you use for linking, and the closer you get to the individual, the more sensible the data become and the more careful you have to be. And if you now look to the research practice, to publications that exist, you can see that this is frequently done in the literature, but not in an encompassing framework. So we always start from the survey respondent, and what we have seen very early in the survey research community is to go to link attributes from survey respondents to other attributes from the same individual, but that were gathered in other databases like official statistical records. You can use the respondent social security numbers, and then you can add more detailed information about this respondent from a kind of objective measurement with maybe less or different errors. And you can also nowadays use information that individuals produce on the web just by living, and then trying to link these digital behavioral data, as we call it at GESIS, to the survey respondent information. And in both cases, of record linkage, of course, you add new information about the individual you surveyed to the survey. And this is very fruitful because you can overcome shortcomings of surveys by having very granular measurements from the external databases. Another tradition, of course, is network analysis, where you link the individual's information on information about the significant other, so the wife, the husband, children, grandparents, etc. And you can try to analyze network dynamics in the networks. So this is very much traditional way of linking, but this could also be covered in a more general framework of data linking. And something that emerged a little bit over the last 30 years is georeferencing of survey data, and then using the coordinates or the location where respondents live, work, or travel with information about these local contexts at different aggregation levels. We will talk about this a little bit more. And then what has been important, for instance, in political communication studies is to link the individuals to the content of the media they consume in everyday life for political information. And this strand of research has gained more importance because more and more things are happening online, and you can track these information online. So you can use a little bit of a combination of content analysis and a record linkage for digital behavioral data. But what you need in any case is a kind of information about the media outlets and their contents, which is not self-evident. And the last, it's an example for a kind of linking through attitude objects. So what do individuals think of, for instance, about political parties, but you could also say churches, trade unions, etc. And then you can link through these attitudes. So the individual has an attitude and the party has characteristics, and then you can link through these attitudes of the individuals and analyze, for instance, how supply side effects in the political competition influence electoral behavior. These different types of linking that I presented on this slide all stem from the literature. These approaches exist, and you could add a lot of references to each of the columns of this figure. So what we now want to do, after having this very general start into the idea of linking and the practice of linking, is to focus for our presentation on 4 challenges that we would like to raise, because our goal now is to set a little bit the scene for the upcoming talks during this semester, where our colleagues that have much more detailed knowledge about what happens with data linking will present their specific research problems and research opportunities. So the 4 challenges are the following. The first is crucial for record linkage. It's obtaining consent for linking. This is required. You cannot do so without the consent, which this would be forbidden. The second is identifying respondents' treatment status in experiments. This is very innovative. This is a novel approach and a novel concept of linking that Sebastian will present. The third one is a classical problem from data analysis in geography that now applies also, of course, to social sciences, is choosing the appropriate level of spatial aggregation if you're doing georeferenced analysis. And the fourth one is also linked to one of the dimensions of our data space, is aligning temporal units, because your data often do not refer to the same time points. So I would start with recently published evidence on the problem of obtaining consent, and I added here cooperation for linking. So the example I had in my figure was the traditional record linkage, and this is very important and has a long tradition. I would say a long tradition, but at least a couple of decades, because it has been done in Germany despite all the legal problems that are related to this. A recent example that I like a lot is the linked data from the German socio-economic panel with data from the public pension records, so from the Deutsche Rentenversicherung. And this gives you objective measurements of the income a person had over his life, at least until the cut-off points that are relevant for the social insurance. But nowadays, and this is more important for our department at GESIS, is that we more and more have digital behavioral data that creates new research opportunities for record linkage. This is what I raised in my figure. So the most important is to understand better how people use the online world and what effects you can identify on maybe offline behavior or attitudes and political actions. And you have a lot of opportunities. You can go to social media platforms like Twitter with all this public data. You can try to get data from Facebook and others, data from mobile devices, as we saw with the example of the PASS panel at the IAB in Nuremberg. And you have the user trackings of online behavior, like web trackings from browser applications. But you have also user trackings, for instance, from service providers of cars and bikes in larger cities. All these data are easy in a technical sense to link, but you need consent to linking. This is a legal restriction, luckily, because no one of us wants that someone does anything he wants with our data. There is now more and more research out there on how this cooperation in linking can be obtained, and we had a common study that was especially done by Henning Silber and Johannes Breuer about what are the different steps of linking that lead to potential bias. And this is part of the results we had. So we had online surveys running in a non-probability sample, and we asked them if the people had, for instance, a Twitter account, a Facebook profile, or Spotify account. And then in the second step, we asked them whether they would agree to be tracked on Twitter, Facebook, or share the Spotify data. And then we collected the IDs for linking to our survey data. So who is this person? And then we looked how many people we could really track. So we could gather data through the APIs or through data donation procedures from these individuals. And what you see here is that, first of all, Facebook is widespread, but not, for instance, Twitter. This is a pity because Facebook is very closed regarding data access. Twitter is very open. And what we see is that from those who received the question about the Twitter account, only a share, then the sample size is always the same. It's about 1,300 persons. Only a part agreed to get tracked, which is understandable. Then we lose a couple of people who don't know their Twitter handle, which is also understandable. And then you see that even for those where a Twitter handle is available, only a smaller proportion can be tracked. So in the end, we end up with not even 20% of valid people from the initial sample that will produce Twitter data. The numbers are similar, a little bit better for Facebook because the platform penetration is simply higher. But here, the skepticism about getting tracked is higher. So the amount of people who have been asked to provide their Facebook ID and accept to be tracked and then are tracked is lower. And here the interesting thing is we could not just go through the API, so they had to install a tool on their browser that would then track the public parts of their Facebook feed. And here you see that this technical implementation in the end led to quite a few dropouts. And for Spotify, again, the penetration is low, but in the end we have roughly half of them agreeing and being tracked in the data. So we had the problem of data platform penetration, then the consent to the linkage leads to data losses, cooperation to linkage, which means that the people have to install something or to provide information about their identity, and then we have problems with the data ingest. And at each of these 4 steps, you lose people and you probably have more or less systematic bias in your data. And this bias is correlated to characteristics of the individual. So here's the second part, because we have survey data on these persons. So the consent strongly depends on age and sex and intensity of platform use. So those who are more active on platforms agree more often to the tracking. This is probably due to the distribution of activity on the platforms, because those who are only lurkers, who never post but always read, probably don't think that their profiles are interesting. So what we can conclude a little bit from these recent studies is that linkage probably needs small but significant incentives. Also, this is not significant here, but it turns out to be a precondition. Minimum burden for respondents, so no difficult technologies to install. And of course, as a researcher, you have to be compliant with legal and ethical standards, which means that you have to prepare a good consent form, for instance. And with this, I would close the first example and ask Sebastian to present the second one.
Yes, thank you. And the second example is trying to avoid bias completely. It is about linking survey data with experimental data. Experimental data are the gold standard in achieving causality, because if we have two groups that differ by nothing else but the treatment they received, we are pretty certain that the treatment was the cause in a change in a dependent variable. Now, in the social sciences, survey experiments prevail, where the treatment is assigned in the same go as the outcome is tracked. That is, the same survey provides the treatment and traces the response to the treatment. So here linking is trivial, of course. The problem with survey experiments is that the treatment you can convey in a survey experiment is usually just a soft treatment, like a vignette or a certain text bit that tries to induce a change in the respondent. Now, these are not always comparable to real-world interventions, such as policy changes. That's why real-world experiments tend to be more valuable to social science research, but more difficult to implement due to ethical concerns, but also due to data privacy concerns. Now, let's assume a situation where we have overcome the ethical concerns and a government or non-government organization agreed to assign a treatment randomly to a subsample of a population. Then we are still stuck with the problem of data privacy. Usually these organizations are not allowed to provide details about the treated respondents because they have not provided consent to this experiment they don't know about. What one can do is, of course, is conduct a survey in the area where the treatment was employed and ask people, have you received the treatment or not? The problem with that is self-reporting is unreliable, especially for socially desirable traits. So we present here a solution to that, which is a pseudo-randomized assignment of treatment. That means assigning a treatment with a deterministic rule that is thus fully replicable, but that results in quasi-random distribution of treatment. And I will show you an example on the next slide. This is research conducted in Botswana. We cooperated with a tax agency in Botswana to randomly assign a text message advertising electronic filing of tax returns. Now, the tax agency was willing to send out this message. They were not allowed, however, to share with us the addresses of the treated respondents. This is what is shown in the taxpayer database on top. Now, we did conduct a survey below, the table below, which shows you how we traced the outcomes. We asked people whether their needs were addressed by the government. Now, in order to reliably know who could and could not have received the treatment, we only sent the message to people with a phone number where the last digit was between 0 and 4. People with the last digit of the phone number between 5 and 9 did not receive the message. So from this, we could infer the treatment status of all respondents just by asking for the last digit of the phone number. We also asked them explicitly, did you receive the message? And the interesting thing was defining the treatment status by the last digit of the phone number resulted in a perfect balance between treatment and control group, the way it should be in an experiment. Asking people directly for whether they received the message, the treatment, did not result in a perfect balance, which indicates that linking real-world experimental data with survey data works better using pseudo-randomization techniques than by asking for the self-reporting of the respondents. And that is the example of linking with experimental data. Pascal will now talk about space.
So the examples we had up to now were examples where we stood at the individual level. So we basically where we talk about record linkage without official statistics. More important in research probably have become applications of spatial data in research. And spatial data is, roughly speaking, used to model the individual's living conditions, where they are, of the context, very small granular context or larger context. So for instance, my brilliant colleague Anne Stroppe has prepared this very nice map where you see how the quality of access to railway infrastructure is in Germany, where the small black bullets are the train stations, and the color of the map represents the distance, the average distance to the railway station at your municipality. So this combines very fine-grained information about infrastructure with more or less aggregated information about the quality of access. And georeferencing means for surveys that you transform the indirect spatial references that you have, zip codes, addresses, codes of the municipality, into direct spatial references. And this means that you have geo-coordinates computed for every point where your respondent lives or for an area where the respondent lives. So for instance, if you don't know the exact address but the zip code, then you can simply use any point of the zip code area to assume that the respondent lives there. In the general case, the smallest error, of course, that occurs for the midpoint, the so-called centroid. And these georeferences are then projected into a geographic coordination system, which is a little bit more complicated than that what we learned at school, because the our planet is not flat, but it's round, it's a ball, and so you of course have to take into account this form. And what then social scientists are interested is in data, spatial data about space usage, infrastructure, population composition, and distances. I won't talk too much about distances because what interests us today is the problem of choosing the appropriate level of spatial aggregation. So what is the problem here? It's called the modifiable area unit problem, and I can show you a small map where you can see the problem. So the problem is, depending on how researchers choose their spatial units for analysis, the results of the statistical analysis change, because spatial units and spatial data are to some extent arbitrary. So here you see an example that was compiled by Stefan Jünger, also a colleague that works a lot with spatial data, where you see that we have these points, these orange points here. This is where our respondent lives. This is always this household or approximately. And then you have different layers of spatial data in different formats. So here you have noise data. This is of course city of Cologne. You have the share of immigrants living in the neighborhood, but aggregated on 1 square kilometer grid data. And here is the soil usage, the green effort here. And then of course these are only the raw data that are provided from the spatial data administrations. This is, for instance, an EU data set on noise that is mandatory to be collected by the municipalities, and the blue ones are aggregated data from the census 2011. Very different data than then are, let's say, projected into a geographical coordinate frame, but on a very arbitrary way. So the borders of the 1 square kilometer grids, of course, are completely arbitrary. And the problem is now that we have a scale effect and a zoning effect in the treatment of geographical data. The scale effect means that you have different variation depending on how you aggregate your spatial data. And the zoning effect is how you create the zones where you define specific, let's say, neighborhoods, for instance. I show a small example. And these scale effects and zoning effects have strong consequences for the results of your analysis. So this is an example also from Stefan's work. So Stefan, for instance, analyzed how the neighborhood composition influences attitudes towards immigrants. So neighborhood composition of migrants, of course. And now the question is, or the assumption is, that if you live in an area with very few immigrants, but you are surrounded in a neighborhood of a lot of immigrants, then this might negatively affect your view on immigration. But what is the neighborhood? As you see here in number 1, you can have a very, very narrow definition, just taking a 1 square kilometer grid as your living position, and then define just the neighboring 1 kilometer grids as the neighborhood. Or you define the living position a little bit more extensive and a smaller neighborhood. Or you say, okay, this is my living condition and the whole municipality is my neighborhood. And because we don't know how people really perceive their living condition or living place in the neighborhood, we don't know how to model it. So we need a lot of theoretical assumptions about the data. And there is an excellent application to real-world data of this problem by Hilmert and colleagues. Hilmert, by the way, is also a member of the coordination group for Albus. And he analyzed with his colleagues the relationship between migration and income, and used simple OLS techniques, multi-level techniques, and geographically weighted regression analysis. And this is the result for 3 covariates: years of education in blue, sex in red, the more red map, and then the last one is the migration background. And what you see here is that you see very different correlation. In the West it's negative, and in the East it tends to be positive even. And the negative effects, you would not find them in an OLS regression or in a multi-level regression, because the clustering of migrants in space leads to an overestimation or an underestimation of the income gap, because the immigrants live in Western Germany where the average earnings are higher. So if you mix them up with Germans from East Germany in one sample that have lower average income, then it seems that migration has no negative effect on income. But this is not true. And if you use the spatial weighted regression, it turns out that there is a huge difference between the simple models and the more complex models accounting for spatial clustering in your data. And this is the reason why we have to be very sensitive if we use contextual data, how to model it. And even if we do not use it, we should always think about what could be an effect of spatial clustering or spatial distributions of our variables on our results. So this is a topic where a lot has been done, but a lot more can be done. And now Sebastian will talk about the problem of aligning temporal units.
For time, we have a very similar problem as for space, because there's no natural unit for our data, neither for survey data nor for the other data types we usually tend to use. We have to think about how do we properly aggregate data in terms of time. Do we look at days, weeks, or months? We have to decide on where we segment the data temporally. Does the week start on a Monday or on a Sunday? And we have to define temporal boundaries. So where do we start our period of investigation and where do we end it? All these issues can change our results. And this has been recently labeled the modifiable temporal unit problem, in line with the modifiable areal unit problem. So what's the solution to this? Well, as often in social sciences, we need to properly theorize where our data generating process is taking place. And we look at an example on the next slide, a theoretical example. So let's assume we are trying to model whether a person quits their job or not. And the plot on the right side, on the x-axis, shows you the days. And on the y-axis, we have the probability of the person quitting their job according to 2 different models. And we observe the persons quitting their job on the 6th day, but our models, based on survey responses, predict that the person, one model predicts that the person would quit on day 1, and one model predicts that the person would quit on day 4. The problem here is, like with our standard approaches, we would assess both models in the same way. We would say they both fail to predict quitting the job. We don't account for the distance of the temporal distance of the prediction to the actual outcome. This is what has been called the temporal residual problem by Cieflicki and colleagues. So what can we do about it? We can just take longer temporal aggregations and combine 3 days, the plot at the bottom. And then in the first 3 days, nothing happens. But in the second 3 days, days 3 to 6, model 2 predicts the person is quitting, and we observe the person is quitting. So we suddenly have a perfect model. Now, is this useful? Well, it can be, but it doesn't have to be. Let's look at an empirical example. This is from Weisinger in 2016. He's trying to predict the defection of countries from wartime coalitions. And in the graphs you see on the x-axis, the temporal aggregation, how many days have been taken together as a temporal unit, starting at 1 day and going to over 70 days. And you see that the more days we take as a temporal unit, the higher the predictive power of our models as measured by the area under the receiver operating curve or area under the precision recall curve are. So does that mean that longer time spans are preferable? Not necessarily. Longer time spans can lead to higher power of our models because the variation between observations increases. But smaller temporal units can also in some instances lead to higher power of the models because we're inflating observations, we're recycling information about issues that are slowly moving and not should actually not be taken into account several times. So here again, the solution is to carefully theorize time and to properly know the temporal traits of the data you're using. How was the data generated? What time spans does it cover? And how have the segmentations been made? So we will look at the future of survey linking now. We think the potential for linking has grown exponentially, not least since the digital revolution. And augmenting survey data provides lots of opportunities, but with the opportunities, the potential pitfalls have also grown. And carefully theorizing space, time, and actors is certainly good advice. But we also have to know our data generating processes of all data sources in detail to make the right linking decisions. On top, many linking applications are scalable. So we think that talking about linking is a good way to start, and our colleagues will talk quite a bit about linking in the coming months. And we can also use community-built open source solutions that help us create economies of scale for data linking. So let's take a look at what's coming up. In the next session in December, Marlene Mauk will talk about time, actually, when she tells us how she linked surveys with electoral integrity assessments. But then in January, Anne-Kathrin Stroppe will refer to space using the geo-coded German longitudinal election study. In February, Boris Heitzmann will introduce you to Eurobarometer and potential linking and extension applications. In March, Sonja Schulz will introduce you to the Albus cumulation and how we can use this data over time. And in April, Stefan Jünger will introduce a geocoding tool that allows you to flexibly link survey data with geospatial information. Well, and with this, we would like to thank you for your attention